में क्या चद्दर मेरे पैर पे चढ़ा तो बहुत अच्छा काट रहा है। चद्दर चढ़ा चद्दर। Hello, am I audible?
Yes, sir.
Yeah. Like, is Kongwei coming today?
Yes, sir. We have to wait.
Okay, I'm waiting for 2 more minutes. Last time only Kongwei was there, na?
Yes, he.
Last class for physics, who was there? Kongwei, am I audible? Hello, everyone, am I audible? Nitish, am I audible?
Sir. Yes.
Okay, switch on my videos.
Sir.
Please switch on your videos. Okay. Can you see my screen?
Yes, sir. Yes, sir.
Last time who was there? Only Kongwei was there, na?
Yes, sir. I was out.
And Nitish, this is
Yes,
the
I
first class
went
for you
out.
for motion. In which topic?
Sir, we when I was there, we stopped at measurement of time only.
Measurement of time doubt. Okay, let us start with that. Go on. Ask it out.
No, sir. I don't have any doubt.
Doubt or no doubt?
No doubt.
Okay. So, who was not there with this chapter starting? Motion in one dimension?
Sir, I was in there. Sir.
Okay. So, I'll just give you some brief about it. Okay. And Kongwei, just listen
Yes.
here. If you can recall everything or not. So, physics is a subject that is divided into two major quantities, that is scalar quantity and vector quantities, right? What are scalar quantities? Those quantities which require only magnitude and no direction. Okay, directions are not required to specify it, that are called scalar quantities. And in vector quantities, we need directions to specify. We need both magnitude as well as direction. For example, if I say that 5 meter towards east, so 5 meter is the magnitude, the value, and east is giving us the direction. So this whole concept is about the vectors. And in case of
Yes.
scalars, you just need the magnitude. Let us say 5 meters. That is the magnitude. Okay.
Yes.
Then we learned about rest
Yes.
and motion. Rest is something like when a body is not changing its position with reference to the surrounding. Surrounding means whatever it has nearby. So then that is said to be at rest. And if it is changing, it is said to be in motion, right? One more thing, rest and motion are relative term. A person can be at rest with respect to one thing and can be in motion with respect to the other. Do you agree? Or not?
Yes, sir.
Okay. One more thing. Yeah, for example, in this bus, see in this bus. See in this bus. Like 3 persons are there, 2 persons are in the bus, and 1 person is outside. So according to the person outside, both the person inside the bus are moving,
Sir,
isn't it? According to the person who is outside, both the person who are inside are moving or not?
yes, sir.
Okay. But if you're sitting inside the bus and your friend is sitting beside you and he is sleeping, he's not moving, so will you say that he is in motion?
Yes. No, sir. No.
According to you, it will be at rest, he will be at rest, isn't it?
Yes.
So that is relative term. One person can be in motion and can be at rest with reference to different objects. Let us say that this object, this man is in space, okay, outer space. So according to him, all three of them are in motion. Why? Because this Earth is rotating or revolving around. Are you getting my point?
Yes, sir.
Right? Okay. So this was it. Yeah.
What, sir?
Distance and displacement. Distance is the actual path traveled. Like if you go from A to B with this path, this path. Okay, so that is called the distance, and displacement will be just this straight line between initial and final point. There's a difference between distance and displacement. Okay, these are the differences between distance and displacement, right?
Yes, sir.
Then speed and velocity. Speed is the rate of change of distance. That means that with reference to time, if the distance is changing, if the position is changing of an object, okay, and that is
Yes.
distance, not the displacement. So that is called the
So
speed.
velocity
And
is speed in a direction.
yeah, and velocity is something speed plus you have to specify in which direction that speed it is. Got it? So there are different kinds of speed. Uniform speed, when the speed is uniform, okay, and covers equal distances in equal interval of time, and the speed is said to be non-uniform if it covers unequal distances in equal interval of time. Yeah, conversion of kilometer per hour into meter per second. How we have to do? Tell Kongwei.
So, first divide it by 60. No, no, no. I don't.
If you multiply this by 5 by 18, you get that value into meter per second.
This.
Multiply it with 5 by 18, you get into meter per second. This was one of the questions that we did. And
How,
that's what we did
so
till
if
the
it's
last class.
10 meter per second, I have to multiply 10, wait, 10 with
If it is
5
10
by 11.
kilometer per hour,
5 by 8.
if it is 10 kilometer per hour, so that will be 10 into 5 by 18. This will be in meter per second.
Oh, oh.
Okay.
Yes, sir.
So distance and displacement we have done. Speed and velocity we have done. We have a term average velocity. Average velocity. What is average velocity? See here.
It's
The ratio of total displacement. Total
time
displacement to the total time taken. Total time taken for entire journey called average velocity.
So there's no difference between velocity and average velocity.
Now see, the difference lies here. When you talk about some velocity, let us say a man has house here and he has to go here, B. Okay. So in that case, what happens here? There will be some traffic lights here. There will be some obstruction here on the road. So velocity will not be uniform. Initially, he'll be at high velocity, then its velocity will decrease. Then again, the velocity will increase. Then it will decrease after seeing the obstruction, and again after passing
So
the
we have to
obstruction, the
calculate
velocity will
each of the velocity and then
yeah,
average.
yeah. We have to take that average. So what we do, we like say that the net or average velocity that was there between the points A and B. Okay, so we have to do for net velocity.
Yes.
Got it? That is
Yes.
called the average velocity. The net velocity between initial and final point is called the average velocity. Understood?
Yes, sir.
Okay. So this is called the average velocity, and the velocity is different for different points. Okay. When we take for all the displacement or all the time, that is called an average velocity. For example, let us say initially it had velocity of 50 kilometer per hour. Then it had 20 because of the stoppings. Then it had 0 for some time. Then again 20. Then again 40. Then again 0. Then again back to, let us say, 60. Like that it went. So there were different velocities at different interval of time. In order to calculate the average velocity, what I'll do, I'll take the total displacement. Total displacement, let us say, was x, and the total time taken from the getting this displacement, that was t. So average velocity will be nothing but x upon t.
Yes.
Understood it or not?
Yes, sir.
This was the concept of average velocity. Then we have to see about retardation. So you write this down. You write this down first.
Yes, sir. Finished.
Done, sir.
Pangwe done? Pangwe, can you hear me? Is it
Yes,
done?
sir. He said that. He said he's done.
Okay, okay. The next topic that you have to do is acceleration and retardation.
Sir, yes, sir, I'm done.
Okay.
The unmute
Acceleration.
button, it takes so long to unmute.
Okay, no problem. Acceleration and retardation. See, the displacement is changing at some rate, right? Like initially, let us
Yes.
say that first 5 meters we traveled in 5 seconds. Second time we traveled in
10 seconds.
again in 5 seconds we traveled 10 meters, and then we traveled 15 meters in again 5 seconds. So what's happening
So
here is
this
that
is non-uniform velocity.
yeah, non-uniform velocity is there, because initially the velocity here is 1 meter per second, here it is 2 meter per second, and here it is 3 meter per second. So what is happening here is that your distance is changing with respect to time, and that gives us what? Velocity. Like if
Yes, sir.
distance covering of distance changes with respect to time, then that is said to be as what? Velocity.
Yes.
Simultaneously, what happens here, if we change the velocity, like initially let us we had 2 meter per second, then we changed to 4 meter per second, then we changed to 6 meter per second, let us say that, right? And then we change to 8 meter per second. So velocity is also changing. So change in velocity there in 1 second, how much change was there? 2. In next second it was 2. In next second it was 2. So change in velocity, or if I must say that, the
Uniform.
rate of change of
Sir,
velocity. Pardon?
sir, I have a doubt.
Go on.
Sir, So let's say we take the time, let's say a car is traveling for 10 seconds, and let's say I take the time interval for measurement for the uniform velocity measurement as 5 seconds. And
Okay.
if the car moves 5 meters first 5 seconds and 5 meters in the second 5 seconds, we call it uniform speed, right?
Yeah, it has to be like equal intervals, equal
Oh,
distances
so the
in equal
first one is
interval.
also uniform because it's 5
So
between.
what if the
It should be 5
what if the
uniform
car
distance,
moved
like
in uneven speed?
and covered
No,
equal
sir, I'm
distances.
asking, what if the car moved in, sir, I'm asking what if the car moved in unequal distance and equal time between the intervals, sir?
Unequal distances in equal time. I could not understand you.
No, sir, like you say there's 2 seconds time difference between this 2, 4, 6, and 8, right, sir?
See, I'm not understanding two things. Like if you're saying that when the speed will be like different and it is covering equal distances, so will that be uniform motion?
No, sir, it's fine, you can continue.
And like try to explain you once again what your doubt is.
Sir, like let's say a car travels for 10 seconds and we
Okay.
take the time interval as 5 seconds and 5 seconds.
Okay.
And in the first 5 seconds, the car travels 5 meters. And in the
Yeah.
second 5 seconds, the car travels 5 meters too.
Okay.
So this is uniform speed, right, sir?
Yeah, this is uniform speed because like in the first interval that you're talking about, the speed is what? 1 meter per second only, and the second interval again the speed is what? 1 meter per second only. That is uniform
Sir.
speed only.
So what if what if, let's say in the first half the car traveled 4 meters in 3 seconds and 1 meter in the rest 2 seconds of the first half. So isn't that unequal distance?
So then you have to divide it, na? Then you have to divide it into 3 halves, and that will be like a non-uniform motion. Then it won't be 2 halves. Why did I change it into 2 halves? Because what happened here is that for the 5 seconds it was traveling the same quantity. Okay, the 5 seconds it was traveling with the same speed. That's why I did it for 1 half. Okay, and then I desegregated into 2. When you have to do this like this, you have to make it into 3 parts like this. So that will be different. V1, V2, and V3. All these will be different. Okay, are you getting it or not?
Yes, sir.
Okay. Now let us move on to the acceleration part. So you write this: the rate of change of velocity with time is acceleration. Written?
So I finished.
Sir,
Where written?
yes, sir.
So this was acceleration that we talked about. Okay. Next thing that we have to do is retardation. What is retardation? Retardation is something to do with brakes. See what happens here. How does brakes get applied? Like let us say that there is a car that is moving in this direction, okay, with some acceleration a. Like its acceleration is constant, that means velocity is changing with respect to time. So it is moving with an acceleration a in this direction, okay, and it has to apply brakes. So what will he do? The car, what will it do? It will apply the brakes like an acceleration in the negative direction, in the opposite direction. Okay, that is called a retardation. Apply the brakes in the opposite direction. It will apply the acceleration in the opposite direction. So acceleration in the opposite direction, that means there will be a negative force on your motion.
Will be
Yeah,
negative.
negative force on your motion. Got it?
So it's necessarily not reversing, right?
Yeah, it's kind of reversing. It's not reversing basically. It will be providing the reverse condition so that there will be acceleration in this direction. Okay.
Oh,
So acceleration in this direction, that means it will be stopping in this direction. Are you getting me?
yes.
Acceleration in the opposite direction means stopping in the forward direction. So acceleration in the opposite direction is called the retardation. Understood or not?
Yes, sir.
Okay. Now it has to be written like this. If velocity of body decreases with time, the motion has said to be retarded or in retarding motion.
So did it follow? So
Yeah. Did you
did
understand
it
this or
follow,
not?
sir? Yes, sir.
Okay. Any doubt till here?
No, sir.
Okay. So we'll solve some questions now.
Oops.
We'll solve some questions. Okay. So acceleration is change in velocity. Velocity of final minus velocity
Initial
initial upon
by
time taken to
time.
change it. Yeah, time taken to change this velocity. Write this down and we'll solve some questions now. It's unit is velocity upon time. That velocity is meter per second divided by time, that is second. So it is meter per second square. Like this it has to go.
So, but shouldn't it be meter per second, sir?
No, see, velocity is meter per second already, and you're dividing it by time again. It is like this. See, velocity is meter per
So
second.
the S
You have to
and
divide
S
it by
should be
time.
cancelled, right?
Meter per second into 1 by second. That is meter per second square. Got it?
Oh, yeah, okay. I thought you just
Yeah.
cancel out the S and then just be meter.
No, that will get divided now. That will get divided.
Oh,
Are you
okay.
getting me or not?
Yes, sir. Finished. Right.
Done, Kongwe?
Yes, sir. Yes, sir.
There is a term called acceleration due to gravity. Acceleration due to gravity. You know what is it?
Speed increases due to the gravity of our planet.
When a freely falling body, when a body falls freely under gravity, it feels an acceleration. The acceleration produced there used in body due to Earth's like gravitational field, called acceleration due to gravity. Okay, see, like when you just leave the ball and it falls without any force, so it falls because of the Earth's pressure or Earth's force that has been applied to it to come towards the Earth, isn't
Gravity.
it?
Yes, sir.
That is gravity. And when it comes towards the Earth, there comes a force, and where there is a force, there will be mass times acceleration. So acceleration will be there whenever there is a force. Whenever there is a force, there is some kind of acceleration, right?
Yes, sir.
Understood? So whenever there is a force, there is an acceleration. So that acceleration in case of Earth and freely falling, like you're not forcing it downwards, you're just leaving it and it is falling under its own. So that acceleration due to gravity is called g, and that is 9.8 meter per second square, exact value at the poles. Okay, it is different for different places. Got it or not?
Yes, sir.
Write it down fast.
Yes. So square. It's square, sir.
What time drinking?
No, sir. I'm telling. Is it meter per second square?
Yeah, because it is an acceleration now.
Oh, okay, sir.
Acceleration is meter per second square. How you got? Acceleration is velocity by change in velocity by time. That is meter per second divided by second, and that gives you meter per second square.
Oh, oh.
Kongu, any doubt there?
No, sir.
Okay, good. Everyone,
Sir.
is it done?
Sir.
Or not?
Sir, finished, sir.
Now, before solving some questions, I need to teach you something about graphical representation of linear motion. We'll be doing graphical representation of linear motion. Okay. Before solving numericals, we'll do this. So graphical representation of linear motion means what? So first we'll study distance time graph. First one, that is, we have to study different graphs. Distance time graph, that will be studying first.
Yes.
Or better, let us call it displacement time graph. Both are different. Displacement time graph, right?
Yes.
Okay. So what is displacement time graph? Displacement time graph is a graph drawn between displacement and time, considering as a two axis, like displacement here, and time here. Are you getting it?
Yes, sir.
Displacement and time graph. Got it? Now see, what you have to do here is that there are different concepts, different graphs that are drawn for different situations. If we consider situation A, body at rest. If the body is at rest, that means it is not moving.
Straight
Okay.
line.
Yeah, its body is not moving. So it will be a straight line. Why? Because let us say that its initial position was at something. Let us say some displacement from the initial the observer. Okay, and with reference to change in time, t1 time the body was then and there itself, t2 time the body was there itself, t3 time the body was there only. This body with this position was not changing.
Is
So
the
when you find that,
body at rest or is the velocity at rest, sir?
no, body at rest means that body is velocity zero. Velocity
Oh,
zero, no velocity.
so because
See,
when
at
they
T2,
reach
at
class,
T2, let us say that initial displacement was x. So at T2, what is the displacement x? At T1, what is the displacement x? So net
X.
displacement between the two time interval is what? Zero. That means the body is not moving, isn't it?
So when they taught us in class, I thought when the body is at rest, the displacement is zero, sir. So I was very confused why they put the line in the middle and not at zero.
That's what I'm asking you. That if you consider 2 points at two different time intervals, T1 and T2. So when we found the displacement at both the positions, is what say it was same. It was giving the same value of y-axis. So when you subtract to get the displacement, that is zero. That means between the time interval t1 and t2, no displacement has occurred. Are you getting me?
Yes.
That is what said to be as displacement zero. Body at rest. Agree, Kongwe? Do you agree with me?
Sir. Yes, sir.
Okay.
Yes.
Now the body is moving with uniform velocity. Uniform velocity means what? If we say that the velocity is 5 meter per second throughout the journey, that means what? In every 1 second, the body is covering 5 meters. Do you agree with me?
So 1 second will be 5 and 2 seconds will be 10. 3 seconds,
So it will
15,
be
like that.
straight line like this. For one, it will be 5. For two, it will be
10,
10. For
15,
three, it will be. It is
20, 25, like
bound
that.
to get 15. You can calculate for
Yes.
4 also. It is bound to get 20. Agree with me or not?
Yes, sir.
Okay, because it has already been said that the body is in uniform motion. That means the body is bound to get that velocity. Agree?
Yes.
This is the displacement, and this is the time
Time
axis.
graph.
Okay, and that is the straight line. How the question will get asked? They'll ask to show the displacement time graph of a body with uniform velocity. I'll do. You will show the displacement here. You show the time here, and you'll draw a straight line, right?
Yes, sir.
Any doubt in these two?
No, sir.
Okay, then draw this out fastly.
So finish, sir.
Everyone,
I finished.
wrong way done.
One
Wait,
second.
it is done. Is it done?
1 second, sir.
Do it fast.
Sir. Yes, I'm done.
Done? Shall we move to the next page?
Yes, sir.
Okay. See here. Um, one thing needs to be noticed here. Let us have that we have a graph like this. We have a straight line graph like this. It is pointing 1 second for 5 meters, 2 seconds for 10 meters, like this it is pointing, right?
Yes, sir.
So we are not given with the velocity. This we are given with the displacement, we are given with the time wave, but we are not given with the velocity. Okay. So how we'll calculate the velocity? For that, what you have to do, we have to find the
So
slope
if
of this
any-
graph. So do you know this what is slope and how to calculate it?
Yes, sir.
Slope is the relative inclination with the x-axis taken in anti-clockwise manner. This is called slope. Okay. Slope is tan of this angle theta. You know what is tan theta? That is something related to trigonometry. Trigonometry we'll do later. Okay. Something related to trigonometry. What you just need to do is tan is the tan of any angle we find by finding the ratio of perpendicular to base. To calculate slope, what we have to do, we have to find the ratio of perpendicular to base. For how? See here. If I extend this line here, if I change my color. If I extend this line here and from here it is here. So if this is theta, this will also be theta. Anyone tell me the reason?
Sir, it's
Tell me the reason for this.
opposite line by the adjacent line.
It is corresponding angles of parallel
Yes, sir.
lines. Got it?
Yes.
So for this theta, this front one will be the perpendicular line and this one will be the base.
Sir, it's
Agree
opposite
with me or not?
side and adjacent.
So this one is the perpendicular, this one is the base. Agree with me or not?
Yes, sir.
Okay. Now what is this? What is the length of this perpendicular line? What is this length? How much? Tell me.
Set 5.
Good. 10 minus 5, that is 5. And what is the unit for that perpendicular? Is it meter?
Set 2.
Unit.
Oh, meter. Meter.
Okay, now we have to find the base. Base is this length. What is this length? Tell me.
One second, sir. 1 second.
Yeah.
It's
Yeah,
1
base is 1
second,
second. 2 minus 1 seconds. Everybody agree with me?
Yes, sir. So 5 by 1. This is 5.
So 5 by 1 and what
meter
is
per
unit?
second.
Meter
5
per
meter
second.
per
That is what? This is
The
giving me
velocity.
the velocity. This is giving me what? The velocity. So can I say
So
that
slope is equal to
in
velocity.
displacement time graph, the slope gives the velocity, right? In
Yes,
displacement time graph, the slope gives the velocity, correct?
Yes, sir.
Slope is the tangent drawn to the curve.
Tangent is a tan Q, right?
And theta. This is theta. Theta is angle.
Tan theta.
Oh,
Something like x. When you take variable x, in algebra, in angles we take variables like theta, phi, like that. Slope is what? Slope is tangent drawn to the curve. I'll show you how. You write this all. You write this. Write quickly.
almost.
Sir, done.
Okay, let Nitish also do.
Okay, so finish, sir.
See, I need to show you something. If the graph is not a straight line, if it is something like this, displacement time. So how will you calculate the velocity? How will you calculate the velocity? You'll calculate the velocity by like if I want to find the velocity at this particular time, t time. So I'll extrude this till here. Okay, this is the point where it is touching, and I'll draw a tangent to this like this. You know what is tangent? A line touching exactly at one point of the curve.
Oh,
And this tangent, you have to find this angle theta with the x-axis in the anti-clockwise direction. When you find the tan of this angle, that will be giving you theta. Okay, and how much this theta is more, the value will be more. For example, if I draw that,
sir, I think your voice is.
Yes, sir.
am I audible?
Sir.
Yes,
Can you
sir.
see my screen? Can you see my
Yes,
screen?
sir.
Yes, sir.
Okay. I'm switching my video off actually. The Wi-Fi went off, and I'm sharing my mobile hotspot, so it will be quite blurry there. Okay. So if I draw the tangent at this particular point, I'll draw it something like this, na? With me or not? And if I produce it back, this will be my theta. Let us say this is theta 1, this is theta 2. Which is greater, theta 1 or theta 2? Tell me.
Sir, theta
That's
2.
greater angle. Theta 2 is greater. This
Yes,
is
sir.
0.1 and this is 0.2. If theta 2 is greater, then our velocity will also be greater at 0.2. That means this graph is showing increasing velocity, right?
Yes.
The velocity of this graph is increasing. Are you getting my
So
point?
if I keep the point 2 lower than point 1, the theta
I'll
2
show you.
will
I'll show
be
you one
lesser
example
than
like that.
theta 1.
I'll show you one example like that. Let's just say that we have something like this, and this is my point 1, and this is my point 2. Now tell me, whose velocity will be greater, v1 or v2?
So 1.
Displacement and time. Whose velocity will be greater?
V1.
Way? Wrong way? Which velocity will be greater? Answer fast.
So I think this mic is.
Sorry, sir. I forgot I was muted. It's P1, sir. It's P1.
v1.
Yeah.
Yes, sir.
See, this is the angle. Okay, I'm telling you. I'm telling you why. And this is the angle, right?
Sure, it should not. The tangent should not intersect with the line.
Yeah, we are not intersecting it. We are not intersecting it. We are not intersecting it. See, what I'm doing it here is that this is my theta 1 and this is my theta 2, right? And since it is greater than 90 degree, so it has become reverse now.
Retardation.
Yeah. So in that case, the smaller the angle will be, greater than this. Okay. Are you getting me?
Yes, sir.
Now it is in retardation because the angle has been greater than 90 degree.
4, 3, 10.
You have to understand this. See here, you have to understand this. What's happening here is
Sir,
that if angle,
how do you identify, sir, how do
you
you
can easily identify
calculate
whether
bar
it's
like
90 degree or
the
not. It is exactly perpendicular. It is 90 degree. You can see here. You can identify if this angle is greater than 90 degree. This angle is greater than 90 degree. If the angles are greater than 90 degree, tan becomes negative. That means you are providing negative acceleration. And what do you mean by negative acceleration? Negative acceleration is nothing.
Retardation.
That means, yeah, retardation. You are moving in a particular direction. Let us say you are moving this direction and you're
Breaking
providing
it.
negative acceleration. That means you are pulling it backwards. Okay, you are pulling it backwards. So lesser you are pulling the backwards, more will be the forward acceleration. So you are pulling backwards more in this case. You are pulling backwards lesser in this case. So there will be more acceleration here and lesser acceleration here. Do you agree with me or not?
Yes, sir.
Draw this, everyone.
So why can't I just draw straight line at P2, sir?
Straight line in P2. Here,
Sir,
here.
why?
What kind of
I'm not
straight line you are
having
talking
sir.
about? What kind of
Sir, the
straight line you are talking about?
P2, sir, and the second, the retardation
Here.
one.
You're talking
Retardation.
like here, like this.
Yes, sir.
See, that depends on the curve now. Curve is like this. And here it's P2.
Oh, it should not intersect. Okay.
Yeah, it should not intersect. It should go like this.
Yes. So how do I find the slope with this?
So with this, see, like you just have to find a relative angle, because in order to find the slope or the direct exact velocity, you need to get this angle in value. If it is not given, you just need to compare these things. Like I told you here, theta 1 greater than theta 2 greater than theta 1, that means v2 greater than v1. Okay,
Yes, sir. Finish, sir.
drawn. Shall I move to the next
Yes.
page?
Yes, sir.
Okay, see here. If we have a displacement curve like this, displacement and time. So what has happened here? Initially, the body was moving in a forward direction. The displacement was going on, going on, going on, going on, and after a time, the body turned and its displacement got reduced. See, what is this
Yes.
case? Let us say that you are standing near a tree. Okay, you're standing near a tree and you have to run. So you run for some time, and then after for some time, you take a turn and come back. Okay, so this is this case. But you have to run for like, since it's a straight line, that means velocity is uniform. Velocity is equals to uniform in going from here to here and here to here. It may be different, like if it is 5 meter per second from going from here to here, it may be 6 meter per second going downwards, because inclination has changed a bit. But the thing is that whatever velocity you had here, same velocity will have here. You may change after turning, so whatever velocity you'll have here, that velocity you'll have here. In this line and this line, the velocity will not be changing. Did you understand or not?
Yes.
So you went, your displacement was going on increase, 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 and increase. And then what happened? It started decreasing, 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 decreasing. And then finally, when you reach the initial point, it became zero displacement after some time. Right?
Yes, sir.
Agree, Kongwe? Kongwe, do you agree? Your mic is still mute. Can you listen me, Kongwe? Can you hear me?
Network issues.
Audible, Kongwe, are you here? Okay, no problem. Just message him
Oh yes, I'll do.
because we need to close this and we need to rejoin with a new link now.
So
This was
once,
all for physics. I'll be teaching you somewhat more, okay? And then this chapter will be over.
so
We'll
that
be
means I tell
solving
him to
some
join
questions.
maths itself. So
Yeah, you have to join the maths link. Okay, I'm ending this one now.
okay, sir. Thank you, sir.
Yeah.